Hello, welcome back. Today let's solve Leetcode problem 1862. Sum of all subsets saw totals. Okay, um, the saw total of an array is defined as the bitwise saw of all its elements or zero if the array is empty. Okay, and our, our task is to return the sum of all sort totals for every subset of the given array. Okay, and a subset with the same element should be counted multiple times, and an array A is a subset of an array B if A can be obtained from B by deleting some or possibly zero elements of B. Okay, so for example, we have this array is 1 and 3, so we have 4 subsets. There are empty subset, there are subset has 1 3 and 1 3, so we saw for each subset we will calculate the saw totals, and then finally we will sum it up to receive the final answer. Okay. So for this problem, whenever we see the word subset, right, we will always think about we will always think about recursion, or especially backtracking, right? Because backtracking is a very famous technique that people usually use to generate all possible subsets of a given array. So that is one solution, but in this video I will not use backtracking or recursion to solve this problem. I would like to introduce you another approach by using the bit manipulation. Okay, using the bit manipulation. Okay, so how can we use the bit manipulation? Okay, so our idea is we will map each subset to a bit match of the length n, where n is the length of the given nums. And okay, so for example, let's see, we have array is 1 3, and we have 1 5 1 and 6. Okay, and then for this array, how many subsets do we have? 4, right? And for this array, how many subsets do we have? 8, right? Okay, so the totals of subsets of every array, it always equals to 2 powers of n subsets, where n is the length of the array. Okay, let me move it here. Okay, so for this array we will have 2 powers of 2 subsets, so we have 4 subsets, right? And for this array we will have 2 powers of 3, it is 8 subsets, right? And then okay, so I will repeat again the idea. Okay, so we will try to map each subsets of a bit mass of the length n. So for example, here we have 4 possible subsets, right? It is empty, it is 1 3 and 1 3. Okay, so we will try to map each subset to a bit mass of the length n. So for example, the length of this array is 2. Okay, so we will generate a bit mass has the length is 2. So for example, and where the bit ones, it means the bit mask is present in the array, and we will use the bit mask, the bit of 0, to say is absent from the subset. So for example, this subset is empty, right? So we will represent it by 0 0, and then for this subset we have 1. We will represent as 1 is the first element, so we will represent it as 1 0, and 2, okay, as 2 is the second element and the first element is 0, is absent from this subset, so we will generate it as 0 1. And for this subset, all elements are appear, so that is 1 1, right? So let's try again for this array, right? So we have 8 possible subsets, so they are empty, right? Empty, it is 0 0 0. So as the length of this array is 3, so we will generate a bit mask of the length 3. Okay, and then the second subset is 5, right? It is 1 0 0. The third subset is 1, it is 0 1 0, and then 6 0 0 1, 5 and 1 1 1 0, 5 6 1 0 1, and 1 6 0 1 1, and 5 1 6 1 1 1. Okay. Okay, so yes, so that solves the idea. Okay, and okay, so I think we can dive into the implementation. Okay, so let's say we do have an edge case, that is the array is empty, right? So we will check if nums dot length is 0, we will return 0. Okay, and we will declare, okay, so I think we can declare the answer here 0 and return answer. So finally we also return answer. And okay, so we will have a for loop. Okay, so I think let me declare another variable for the nums dot length. Okay, so we will loop through all the numbers of subsets. So for int bit mask is starting from 0, so bit mask less than mask dot pow to n, right? Smart dot power, which is 2 powers of n, and bit mask plus plus. Okay, so okay, so we will try to generate all possible subsets by we will have another for loop. So for int position is starting from 0, so position less than n, and position plus plus Okay, so we will get the bit at the current position. Okay, so to get get the bit at a certain position. Okay, so we can use this formula. We will get the bit right shift to position and then end with 1. Okay, why? Because when we right shift the bits to positions, uh, we will try to shift the current bit to the end of the bit match, and then we end with 1 to get the bit at the end of the bit match, right? Okay, so we will check if okay, so we will apply this formula. If bit match shift left position and end with 1 is equal to 1, right? So we will equal to 1, and then okay, equal to 1, and then what we do, we will store them, right? Well, we will store them. So we will declare a variable for the sort total. Sort total is equal to 0, and then sort total sort equals to nums as position, right? And then we will add the sort total to the answer, right? So I think that's it for the implementation. Let's try to run. Okay, so we have bat operand types. Okay, should be 2n, right? No. And I think is and 1. Okay. Okay, so looks good. I'll try to submit. Okay, accept.